Now the C-scores, we're going to be starting with the C-scores. C-score is not going to take us that much. As a matter of fact, I'm going to use only this part of our notes. Ignore the table that you see at the bottom. The table we see at the bottom, I put it there for right now. I'm going to be using that for the future lessons. For today, I'm only going to use up to here, okay? So the table at the bottom, we're going to learn how to read the table, but not today. Now, for today, I just want us to start with a C-score. Now, a C-score, it's going to be a formula. Let me give you guys this formula. Our C-score is going to be equal to X, and X is the number we're testing. Okay, X minus the average. Let me call it X bar. I could use the mu symbol. So I'm going to subtract the number we're checking minus the average or mean, however you guys want to call it, divide this by the standard deviation. And that will give us a decimal, right? C-scores are most of the time are going to be decimals. And most of the time I'm going to be rounding to 2 decimal places if necessary. Let's take a look. A normal distribution of scores has a standard deviation of 8. Okay, so here, this is my standard deviation. Find the C-scores corresponding to each of the following values. So my first two examples, my standard deviation is 8. So for example A, score of 60, where the mean score of the sample data is 40. So I'm just going to go 60, because I'm testing 60, minus 40, because the average was 40. I'm going to divide this by 8, which is the standard deviation. Now 60 minus 40 divided by 8 gives me 2.5. Okay, not bad. Was pretty simple. Now let's take a look at example B. A score that is 13 points below the mean. Interesting. Looking at our formula, X minus the mean, that's basically what's the difference between a number that I'm checking. So that really is negative 13 divided by 8. Remember, our standard deviation is 8. So 13 points below the mean. So negative 13. If I said 13 points above the mean, positive 13. So negative 13 minus the standard deviation, negative 13 divided by standard deviation is going to give me negative 1.625. But then I hear it round to the nearest hundredth. So TH means we're dealing with decimals. 100 sounds like a 1 with 2 zeros. So because there's 2 zeros, that means 2 decimal places. So my answer will be negative 1.63. So easy to find the C-score. I'm just looking for the difference between a number that I'm testing minus the mean. When they said a score that is 13 points below the mean, well, they pretty much did the top already. Let's take a look at here for number for the next 3 questions. 3 students take equivalent stress tests. Find the C-scores for each student. Round to the nearest hundredth. So that means 2 decimal places. A score of 144 on a test with a mean of 128 and standard deviation of 34. So the score that I'm testing is 144. So I'm just going to go 144 minus the mean. All of this divided by the standard deviation. 144 minus 128 divided by 34. This is going to give me 0.47. Round it to 2 decimal places if necessary. For B, let me change different colors so we don't get confused, A and B. The score is 90, so 90. The mean is 86, and divide this by the standard deviation. So 90 minus 86 divided by 18, it's going to give me 0.22. And for C, a score of 18 on a test with a mean of 15. So I'm going to go 18 minus 15 divided by the standard deviation, which is 5. So 18 minus 15 divided by 5 is going to give me 0.6. I know I said hundredth two decimal places. I don't need to round this one. It's just 0.6. Now, one thing. In this example, with these three examples, notice how my C-score, they were positive. Now, one thing, they're not always positive. Look on the previous example. One of my C-score was a negative. So C-scores can be positives, can be negatives, okay? That's all I need you guys to do on this section. Easy. The number we're testing minus minus the mean, all divided by standard deviation. So let me say that again. The number we're testing minus the average, all this divided by the standard deviation.